Okay, recording starts now. So we're going to go through the glassware and equipment list. I'm going to just briefly go through the modules, and then I'll go through the picture of the glassware and equipment module, and probably show you a few glasswares. What do they look like? Okay. My modest suggestion to you is that utilize this time. Be organized. I'm not organized. I'm not proud of it. I'm trying to tell our son that don't be like your dad. Be more like your mother, who is more organized and a much nicer person. So some of my students have kind of taught me to be more organized. Like Bob in our group, he just left for a nursing program. Inder, Prarthana, Tani, she's a dental student. Inder is a medical student right now at UCSF. Tani is in A.T. Still University doing dentistry. Some of the recent students have actually taught me how to be more organized. So be organized and utilize the time from 9 to 11:50 to go through all these modules and learn everything. Force yourself to learn everything and watch all the videos, starting from 9 until your next class is. And then you get done with something. Don't procrastinate. See if you can do it. Okay? It is important because when we get to the first exam or quiz, I will be asking you questions from the list of glasswares. Or what is this doing? What is it called? Things like that. And for you guys, since it's a small class, I might do like a free response type of question. So when we start talking about an experiment that you are really not doing in live in the lab, I will be asking you about the mechanism of the reaction, the structure of the molecules, the functional groups, what kind of reaction that is called. We will talk about that in this pre-lab lecture, and we'll be recording it, so you'll have plenty of opportunity to learn it. Okay? Any questions so far? We're good? You guys are staying healthy and as happy as you can? Any random chit chat? Any comments? Anything? How is your life going on? Anything interesting happened in life in the last few days since I last saw you? When did we last meet? Monday.
I have a question.
Yeah.
So for the safety quiz that we took, I know that we had 2 attempts. So are you gonna like give us the highest grade that we received?
Yes.
Okay.
It's automatically counting the highest grade. If I think you guys should have done fine, because some of it is kind of like, I won't use that word. Sometimes I've been told that that's not a very friendly word. Okay. Let me check. Okay. I'm gonna go through the scores and see how you guys have done that. The whole idea is to basically learn the safety concerns and issues. Did you guys go through the modules carefully and made a sincere effort to learn? What do you guys think? Give me a thumbs up or thumbs down, or no thumbs up means you don't know what's going on. Yeah, sounds good. Okay. You feel pretty safe? Yeah, all right. Yeah, so the higher score will be taken and we're gonna go from there. Thank you, Thais. All right, so I'm gonna share screen. Anything else? There is a chat. There are 2 things in there. I'm currently driving, so my webcam will be off for a moment. Okay. That Thais, you're scaring me. I don't want you to be zooming. My brother is talking. Okay. All right. Just don't get into an accident. Don't get a ticket because you're accidentally going over the speed limit. I don't think the cop is going to listen to you if you say that. Actually, I was going to a class, Organic Lab, and the cop will probably give you a funny look. And I was really not trying to speed, but I accidentally sped up. Okay, let's not do that. Just be safe. I don't want anything to go wrong this semester. There is a possibility for many things to go wrong. Let's stay safe and healthy. That's the goal. If you're not safe and healthy, then chemistry and successful reactions mean nothing. Okay, that's why the safety module is so important. That's why I spent 1.5 hours going like with my rant, boring you guys. Okay, anything else? No? Okay, let's share screen. And okay, we cannot share screen, and I cannot show you I cannot turn on the video at the same time. Can we do that? I don't know if I can do that. Let's share screen for a second. I might change it. Screen number 2. Okay, screen number 2, share. Give me a thumbs up that you are being able to see my screen. That, okay, good. Glassware and, okay. Learning objectives: draw, interpret, and convert between Lewis, condensed, and bond line structures. Well, recognize functional groups, recognize elements of a common complete reaction scheme, and draw structures and reactions using ChemDraw. Okay. That looks kind of, okay. Learning objectives: read and watch all content in this module, submit assignments. Okay. Let's see how does it look like. That's a little, ChemDraw is next week. I'll give you guys a link where you can go and download the ChemDraw as a student. Okay. Pictures of glasswares. Okay, so remember what you're seeing here. I'm not going to expand the screen. Graduated cylinders, wash bottle. I don't have a wash bottle in my office yet, but it's pretty straightforward. On the extreme left, you see 2 graduated cylinders. One is a 100 ml graduated cylinder. It can measure up to 100 ml. Please pay attention to this because this is very important. Okay. The one on the right is a smaller graduated cylinder. It's a 10 ml graduated cylinder. Number 2, the white bottle is called a wash bottle. You can have distilled water inside. You can have acetone inside. You can have ethanol inside. You can use it as a solvent squirt bottle. Sometimes we call it a squirt bottle. The difference between number 4 and number 5, there is a difference between them. They both look conical, right? They look like a cone. Back in India, when I was a student, I used to call this guy 1, 2, 3, 4, 5. The 5th guy, we used to call them conical flask. I think that's probably more British. Here we call them Erlenmeyer flask, and that E is written with an uppercase E because it's the name of somebody. Okay, it's an Erlenmeyer flask. The last one is beaker. Okay, down here there are a couple of funnels: the plastic funnel with a stem, and the glass funnel with a shorter stem. Then you have test tubes and watch glass. Okay, let's go to the next one. So remember what you saw here. Ground glass joints. So the ground glass joint, the one on the left side, you have a small flask at the bottom. Can you guys see my arrow down here that I'm kind of moving around? You can see that, right? Give me a thumbs up if you can see the arrow. Okay, good. So the one on the left, that little thing, I think it's a 10 ml. They're called round bottom flask. I have an example in my hand. It's a round bottom flask. On top of it, this guy is called a distillation head. There is a joint here. There is something on top of it, and there's a thermometer that's stuck inside. There is another ground glass joint. Ground glass joint means you don't need to put any tape or any rubber septum or any O-ring to make a really tight joint. When you have 2 ground glass joints, usually they're called male and female. When you have the male and female ground glass joints stuck together, they're made in such a way that nothing leaks out from them. It's really awesome. Okay. So when you are actually in a real lab, and if you are going to break something, it's always good to I'm being sarcastic and funny, trying to be funny. It's always good to break a glassware that doesn't have ground glass joint. Why? Expensive. Each ground glass joint used to add like $5 to the value of the equipment. So this round bottom flask has a ground glass joint, a female joint. It's probably more than $5. This distillation head has one and two, definitely two ground glass joints. It's definitely more than $10 worth. Okay. The next equipment is the cylinder with two chambers and two little little connectors to connect Tygon tubing. This is called a condenser. So when you pass water through the outer jacket right here, so this upper connector is for water to come out, and we cannot see the other end. The other end has the water in. Water goes in and water comes out from the other end. I think we talked about it in the past. Water is filling up this outer jacket without touching what's passing through the inside. There are two lines, one line and two lines. The inner line is connected to this flask, to the thermometer, and to the other end. Okay? So the whole idea for the condenser is to pass tap water or cold water. You can actually pass lower temperature water. You can have like ice cold water and use a pump, like a fish pump, to pass that ice cold water through the jacket to keep everything inside the condenser cold. So the whole idea is you distill something from this flask using a Bunsen burner or whatever, or a heating mantle or some device. The liquid starts to boil, turn into a gas, hits this region here, bathes the bulb of the thermometer so that the thermometer reads the exact temperature of the vapor, and you can basically note down the boiling point of the liquid. Then the vapor starts to fill in this, the upper end of the condenser starts to pass through the condenser and condenses into the liquid state. And then on the right side, this distillation outlet or bent adapter, it's called the bent adapter. This guy is attached to the other end of the condenser. It's not a full picture. That's attached, and the liquid, after condensing through the condenser, gets out from here, and you collect it using another round bottom flask or something down here. Okay, this guy, you are just, I think on the extreme right, the picture number C is the picture of the round bottom flask, and you're adding whatever you're going to be distilling using a graduated cylinder. This thing where the round bottom flask is sitting, it's called a cork ring. I remember my first PhD advisor used to get really upset when someone would lose a cork ring, or he would have to buy a cork ring, because it looks like a very cheap material. It probably costs like 20 cents to buy one, to make one, but they used to sell it to chemistry labs for like $5 or $10. You put the liquid inside using Keen White. Who can tell what's being done before you're setting up the whole distillation setup? What is going on in picture A? Somebody with gloves on is inserting like a piece of paper, like a Keen White, in the upper ground glass female joint of this 10 milliliter round bottom flask, where you have just added whatever you're going to be distilling from. Who can share what might be going on in picture number A? What is that chemist or the student doing with a piece of paper by inserting inside that ground glass joint? What is going on? I'll give you guys 2 minutes to think. I'll give you an example. Let's say you're cooking something. What's a good example? Okay, let's say you have an empty, almost empty bottle of olive oil. okay? And for some reason, you fell in love with that bottle of olive oil. Even though there is no olive oil in there, you love that bottle because you like how it looks like and how it fits in your hand and how comfortable it is to use in your kitchen. Then your mom or dad or brother or someone brings a bigger jar of olive oil, which is kind of a cumbersome bottle to deal with. And you want to transfer, what you are deciding to do is, I'm going to continue to use my old olive oil bottle, but I'm going to transfer some of the olive oil from the larger container that my mom just got from Costco into this old bottle, okay? And you have been very careful. You poured a bunch of olive oil, like let's say 100 milliliter of olive oil, or I don't know, half a liter of olive oil, 500 ml of olive oil into that old bottle, and then you have to insert that cap, and you are kind of an A-type person to close the lid, the open end of the old olive oil bottle, and you don't want the cap or the cork to get too much olive oil and get slippery. So what do you think you will be doing that has some resemblance with what's cooking in picture A? What is this person doing with the quinoa? Please unmute and
Cleaning around the area.
cleaning around the area so there is no liquid in there. You don't want any liquid to be trapped in the groundless joint. The consequence of that scenario can be detrimental. 1, 2, 3, 4, 5. Okay, 14. Okay, 2 of you are not here right now. Okay. So the reason is when you're attaching the groundless joint, let's say you're looking at this A picture. The distillation head is attached to the round bottom flask, and there is some liquid in there. As you heat the whole system, sometimes the liquid stuck in that groundless joint can burn. Okay, the little amount of liquid or solid or whatever you have may get stuck in there, and during the course of the distillation or the reaction, it can burn and act like an adhesive, like super glue. And your groundless joints may be attached forever. And that's a nightmare to unstick the groundless joint. That's why it's a really good idea to wipe it and before you use it. And this is called a glass stopper, picture B at the bottom in the middle. You're just kind of keeping it for some time. Unfortunately, I don't think we have this fancy glass stoppers in our teaching labs. Wiping the joint free of residue, frozen joint. Okay, so apparently it's not a demonstration of a stopper. It's actually a demonstration that this stopper is stuck, and you're in big trouble. Okay, the way you unscrew it undo it is sometimes by heating it with a heat gun very hot very quickly to melt whatever is stuck there and quickly taking off the stopper. And the C is attempting to separate a frozen thing. There are some questions, you'll have to do that. I'm just going to go to the next one. Okay, these are taken from Merlot, UC Davis Library. Next one is a distillation setup. Picture A, round bottom flask. It's what you just saw there. This is the complete thing. And you use clamps to connect your glassware with the monkey bar. You see this little aluminum or cast iron bars in the back? These are called stands. We actually have, if you look at the picture number 7, picture number C, you already have these monkey bars, as if little monkeys will come and play here. So you use this scaffold and clamps. I'll show you the real clamps to hold on to your different glassware. These ring stands are pretty shaky actually because they can move around. They're extremely dangerous. I hate them. I personally don't like them. Okay, I like monkey bars as shown in picture 7. I don't like these ring stands because they can move and they can completely unsettle the whole apparatus. So round bottom flask, distillation head, ground glass joint. This is a clamp attaching the round bottom flask to the ring stand. That's a thermometer. Thermometer bulb should be down here so that it's bathed with the vapor properly. We'll discuss it later on. That's a plastic clamp to keep that thermometer stuck to this upper end of the distillation head properly. It doesn't come off. There is also a yellow clamp to make sure that in the middle of the distillation, the condenser doesn't come off. The condenser, the hoses for water. The one on the right side at the bottom level is water in. Always the water in is the bottom one, and water out is the upper higher one. This is a bent adapter. At the end, again, there is a clamp so that they don't get disconnected. And you are connecting the distillate into a what do you call, graduated cylinder, so that you can measure, like, half mil was collected in such and such time, such and such 1 mil was collected at such and such time, and you can actually draw a graph by plotting the volume of distillate, what comes out, and the temperature. Then you can actually draw a graph. You will actually be doing it. So this is very important, this picture. Something is incorrect, you can look at it later on. These are different.
Question.
Yes.
Going back on the previous, how will you set up what's on A on C? Because I was kind of wondering, like, does the distance matter?
Okay. So your question is, how do you do this setup using the scaffold that looks like this? So okay. So what's important here is the glassware setup. Okay. The important part is the round bottom, the distillation head, thermometer, condenser, vent adapter, and the collecting graduated cylinder. So I'm going to quickly switch to, like, disconnect it. No, I'm not going to disconnect it. I'm going to show you the real stuff using the glassware that I have here. That will probably make more sense. So what I'm trying to say is that this part is important. The ring stand and the clamps are just to connect, to hold your glassware in place. In picture A, you're using ring stands. You see the bottom of the ring stand? The reason I don't like them is because during the course of the experiment, someone can knock it over, like an unassuming student who is not really paying attention. He or she can come and accidentally push this thing. This entire thing is going to be toppled, and your glassware is going to break. There will be liquid everywhere, steam everywhere, gas everywhere. If you attach this whole glassware setup, round bottom flask, distillation head, condenser, vent adapter, and the thermometer, if you put it on C, and if you clamp it using the monkey bar here, these monkey bars are much more sturdy and they're not going to move. Even if you accidentally run into the monkey bar end on the right side, this part of the monkey bar is not going to be moving or get disrupted to affect the location of your different glassware. So the monkey bars or the aluminum or cast iron scaffold is there just to place your glasswares with security. It's just to kind of like hold on to your glassware. So you use different clamps to hold on to your glassware against a fixed surface or a scaffold. In picture A, the scaffold happens to be just 2 ring stands. They're mobile. You can carry them and move it to the other end of the lab. On picture C, it's a fixed monkey bar system. Imagine all these bars are connected to the floor, to the countertop in this lab, and they can move. So they're just more rigid and more solid, and they're unmovable. They're stationary. So they're going to be more secure. These are different clamps. In picture A, if you look at the back end of the clamp, this guy, so one little part is to secure this part to the monkey bar. Whether it's a ring stand or whether it's the real monkey bar, this part attaches itself to the monkey bar. The other like clamp connects this little rod, which is generally horizontal. And over here at the end of it, you connect your glassware, whether it's a round bottom flask or whether it's a graduated cylinder or whether it's a condenser, that's a different thing. This is a little smaller. This second guy is a little bigger. These guys are called three-prong clamps, and this is not three-prong, it's a little different shape. This is also a three-prong clamp, and it's a little bigger. And this is exactly, if you look at the picture B and picture C, you can see that how one of these clamps in picture A, extension clamp, they're three-finger clamps, so they're called three-prong clamps, and how you're attaching a round bottom flask to the monkey bar or wherever the other end of the clamp is, okay? This is bad. Picture C, this is good, because if you're doing it like C, the whole flask can fall off if it is not secured correctly, okay? Any questions? You guys are getting the hang of it. I know this is the weirdest thing I've ever done in academia. I'm not proud of myself, but this is special time that requires special means and maneuvering through this difficult time. And as I'm convinced that we did the right thing by not opening the in-person lab. My apology for compromised teaching here, but again, I'm going to remind you that if things get better in the near future, we're going to have like a boot camp where you can actually deal with all these things in person. I will be the first person to volunteer instructing there, okay? Down here, these are different types of setups. Again, you're using a ring stand to use a three-prong clamp to hold on to this Erlenmeyer flask that has a rubber stopper with two holes. There's a bent tubing going through here. There's a bent tubing going from the other end, and it's connected to the water aspirator. This is called water aspirator. You don't have to learn about it right now. Don't worry about it right now, because this was a way of wasting a lot of water. It creates vacuum. When I was a graduate student in University of Nevada, Reno, we used to use water aspirators. Now I think about it and I freak out, like, oh my God, how much water we have wasted. Because you pass water very fast right below this purple A with a black letter, or lowercase a. You pass water through this line and it creates vacuum here. So essentially you're applying vacuum here, and this side neck, you are applying vacuum to this filter flask. And on top of the filter flask, you have a little rubber thingy for creating a seal. And this is called a vacuum filtration device or vacuum filter funnel called Buchner funnel. I have a sample of Buchner funnel. So try to remember these. And when you see the video later on, or when you replay the video, and when you see at the end of the video, when I start showing you the real glasswares. Okay, three-prong, I think the examples are just, I think the highlight here is three-prong clamps. How do you, and where do you use three-prong clamps? Three-prong clamp here, three-prong clamp here. It's hard for my tongue, Indian pronunciation of, tongue. There's a three-prong clamp here. There's a three-prong clamp here. This guy is called a column. And this stuff inside is silica gel. And the liquid is some kind of solvent system. And this yellow band or orange band, and this yellow band down here, light brown yellow, whatever you call it, light orange yellow, this is a separation technique. We will talk about it later on. So as you pass a mixture of compounds, a red compound and a yellow compound, which used to be a mixture, when you pass them using a solvent through this pack of silica gel, what happens is they interact differently. Each component interacts differently with the solvent and the silica gel, and they separate. One guy runs faster than the other, kind of like a marathon, and they separate. and the yellow guy you can see clearly that it's separating out faster, and it's going to come out from the other end of the of this column much more quickly, and you can collect it separately from the red guy. So column chromatography, it's a separation technique. That's not the purpose here. Again, a three-prong clamp is being used to hold on to a little pipette. I have a pipette that I brought, and this is a test tube. And you're doing a column chromatography using a pipette with some silica gel and with some solvent. These two, B and C, are essentially the same technique, but one is a large scale, one is a small scale. This guy is called a separatory funnel. When you have two immiscible liquids, imagine this being water and this being vegetable oil. If you're separating that, I'm using this crazy example because it makes sense to you. The top layer is vegetable oil, and you know that oil and water don't mix. So if you accidentally, well, somebody has done it in his life in the past, if you have accidentally added water into your vegetable canola oil, or I don't know, whatever vegetable oil container, and your mom or dad or your sister or your partner got really mad at you, that, oh, what did you do? Separate them. We cannot throw away the vegetable oil. It's pretty expensive. Safflower oil, or I don't know, whatever, canola oil or something that costs a lot of money. Why did you add water? And you're like a scared mouse. You can actually use a separatory funnel to get rid of the water from the vegetable oil and make your mom happy again, okay? And the lower part is kind of tapered down because the amount of the lower liquid might be getting down to like a few drops. And when the separatory funnel has a shape of a cone, you can deal with small quantities better if this lower part is holding on to like less material, okay? And you also have a stopcock. By opening it up and closing it, you can pass the liquid and you can get rid of the bottom layer and keep the top layer, and thereby you can separate. That's why they're called separatory funnel. B is just a regular funnel, and you're just using it to kind of direct whatever you're pouring from here. Excuse me. That looks like a test tube, and this is whatever it is, whatever they're doing here. And this is another example. This is called a short path distillation apparatus. Here is the condenser. I'm looking at picture C. This end goes into the flask, whatever you're distilling. This is where the thermometer is attached. These guys, one of my favorite apparatus in our research lab. You won't get to use it in 129A or B. It's very expensive because it's like 1, 2, 3, 4 things in one. So it's got the distillation head, it's got the condenser, it's got the bent adapter, and it's got the thermometer adapter. This is sweet. This is beautiful. You can see how passionate I get about some glasswares. I actually have a fetish for syringes. I'm not a maniac. I'm a pretty normal, harmless human being, but I love syringes. There can be gas-tight syringe, there can be liquid-tight syringe, there can be syringe pump. They're awesome. I like gadgets. So this glassware, it's called a short path distillation apparatus. This is beautiful. I got very mad when one of my students broke one. I didn't really get mad, but then I was a little disappointed. These clamps, plastic clamps, use of plastic clamps. Okay, there are some questions. I'm not going to worry about it. You can answer them later on. So I'm not going to get into the details. I don't want to bore you guys. It's already 9:42. Drying glassware, you can read that. I'm not going to bore you with that. Figure it out. Okay, this is called a desiccator. This blue stuff at the bottom is something that soaks water. Desiccator means, desiccant means something that reacts with water and makes the environment dry. You have seen noodles or cookies, maybe fancier cookies. It comes with a little pack that says silica gel or something. That stuff is a desiccant. It keeps that environment around that noodles or, I don't know, cookies or candies, it keeps that area dry, okay? So this is a desiccator, and it's pretty cool. It's not that you guys need it for this class. When it's blue, it's dry. When it soaks water from moisture from air, this whole thing turns pink. I think I forget what it is. I think it's cobalt chloride or cobalt nitrate or some chemical. It's primarily calcium sulfate. It also makes things dry, but the indicator, the stuff that turns blue when it's dry and turns pink when it's wet, that stuff is, I believe it's cobalt something. I can't remember what it is. Cobalt sulfate, maybe cobalt sulfate. I'll figure it out. And this is a balloon. Sometimes you run a reaction using a gas. You might be using hydrogen gas. We often do this. We can use like a balloon filled with hydrogen gas, and this fills up the flask with hydrogen gas. And now the compounds in the liquid inside this round bottom flask gets to mix with hydrogen gas and react using hydrogen gas. You can make an alkene into an alkane or alkyne into an alkene using hydrogen gas. C is a drying tube. This is called a drying tube. If you are really paranoid that, oh my God, my stuff in this round bottom flask is so moisture sensitive, it's going to go bad if it sees much moisture. So you stick a little drying tube filled with calcium chloride. Calcium chloride will react with water and become wet, preventing the moisture from getting inside the flask. Okay, it's just a technique. You can figure it out now. Okay, so what I'm going to do now is I'm going to pretty much stop my rant. Let's see what's next. Drawing conventions, molecular module review, structural formulas. This is like 128A. This material is going to be helpful for your 128A material too. Introduction to ChemDraw. Okay, we don't have to do this. So what I'm going to do is I'm going to stop share, okay? And I'm going to switch to the other camera, and I promise that I'll finish in 15 minutes because you have already been exposed to these glasswares. So I'm going to switch to my other camera, kind of focus it to the board. Don't worry what's written on the board. I will always, my Chem 8 class from 8 to 8:50, it kind of went over. I'm going to show you some real glasswares. I'm going to try to like set things up in my hand, and this video is going to be available. So I'm not going to draw anything, so there will be no still picture, okay? Are we ready? Any questions? Any relevant questions? No question is a bad question, okay? It is important to know each and every glassware because of a very tangible, practical reason. Quiz. Again, I'm urging you, I'm begging you to pay attention to what you're learning as theory, technique, glassware names, blah, 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 because you might be doing fantastic elsewhere in this course. But if you start screwing up your quizzes, you will be pushed down to the next lower level, unfortunately, from A to B or B to C. Okay? Don't let that happen. I'm just giving you a friendly reminder that I think you can handle it. Virtual learning has advantage and disadvantage, so turn it to your advantage. Okay. I hope Thais. Okay, Thais is here. Somebody is missing. Page, Elizabeth, Victoria, Jasmine, Shireen, Estefan, Michael, Ramon, Julian, Ramon, Sandra, Chris, Thais, and Harlan. Okay. So what I'm going to do is I'm going to switch to my other camera, and I'm going to just pick up like random stuff. I don't know the exact order by which we learn. Okay. I'm going to stand up. Just ignore what's on the board. Okay. What do we start with? Let's imagine, or you can actually, if you have a screen, I don't know if you can have a second screen. If you think about the setup, right? Um, you can unmute. Anybody remembers what this guy is called? This whole thing is called? Unmute and then talk. I'm not looking at the chat. I'm not looking at the screen. I'm just looking directly into the camera.
Round bottom flask.
Round bottom flask, it's often called RB flask. Uppercase R, uppercase B flask. Because chemists are not lazy, I promise. We are just efficient. And you know, we try to use acronyms and stuff. This is a round bottom flask. Okay. What does this look like?
Condenser?
I'm going to use a different one. Okay. I'm using a different setup because I was missing the condenser. Round bottom flask. Someone said condenser. What's this? You can correct yourself. There are 3 glasswares in this setup. One is a round bottom flask, one is a condenser, and the third thing is not a condenser, something else. What's that? Which one is condenser? This one or this one?
Is the condenser the one on top of the RB? Oh.
What's this? Which one you think is going to convert the gas into a liquid? This guy, I'm going to hold them in my hand. Which one looks like can condense? Which one can be cooled using some technique? One on your left, the tall guy or the short guy? Which one can use a technology to make things cold inside? The tall guy or the short guy? This one or this one? Which one? Which one looks like a condenser? Left or right?
The left.
This is a condenser because what can you do from here and here? You can unmute, everyone unmute. Talk, let's talk.
Water into it.
Water in and water out. And you can see that when I look through it, if I'm looking through it, there is this passage. This is where the material passes that comes, the steam or the gas that comes up from the flask. Where is my flask? I don't want to drop anything, and that'll be a pretty nice demo. The liquid is in here, you're heating it up, the gas goes up, it's closed because you will eventually have a thermometer. It passes through here, through the inner line. And what if the water is going in there to fill up the outer jacket? There's an outer jacket. So outer jacket doesn't touch anything that's inside. Okay, this is a common mistake. That, oh my God, you're passing water, Dr. Maitra, the stuff that's going through it, it's going to get wet. No, it's not going to get wet because there are 2 different lines. This water is going to just pass, flow around. It's kind of like a cooling agent, like a little jacket, okay? So the jacket is going to get cold, and the whatever gas that's passing through it is going to condense. And so we haven't settled something. Round bottom flask, condenser. What is this guy called? Who remembers?
The ground glass joint.
This is a ground glass joint, that's a ground glass joint, that's a ground glass joint. There are 2 ground glass joints here. One is female, one is male. What is this guy called?
Is it a 3-way adapter?
That's very intelligent, but it's not called a 3-way adapter. Distillation head. So you need to, I'm not going to teach you all the names right now, but you need to memorize them. If you don't memorize them, and if you see it in quiz number 1, it's an easy point, low-hanging fruit. Do not miss those low-hanging fruits. Okay, I'm kind of running in the dangerous territory, so I'm going to start clamping them. Okay, there are different size clamps. There are different size glasswares. This joint is called 1922. It says 1922. I don't have to teach you like what 1922 means. This could be a bonus question. Like, what does the joint, this groundless joint says 1922, what does it mean? You can ponder. We're not going to discuss that. So there are different clamps for different size joints. The blue clamps are for 1922s. It doesn't seem to be, I don't want to cause any embarrassing moment for myself. The small clamps, okay, the yellow clamps are for the smaller joints. Okay, this guy says 1410. This guy says 1922. And you use a blue clamp for the 1922 and you use a yellow clamp for the 1410 or 1420. You can think about what do they mean, okay? I'm not going to discuss it right now. So I'm just clamping them just in case something falls out of my hand. I don't want to clean up the broken glass in my office. I'll be the last one to do that. Now it's pretty secure, okay? Then this guy is attached at the end. Now I'm getting into the risky zone of doing something stupid and breaking and regretting. So now your setup is pretty much ready, okay? Only one thing that's missing is this is a wrong size. Okay, this is 1420 joint. Unfortunately, that's 1922 joint, okay? You should not be using it. This is a bad idea. Either we use an adapter that converts the 1420 into a 1922, or you use a different thermometer adapter that's bigger, okay? This is smaller. So this is, I'm gonna just set it up here just to prove a point, but this is bad. This is a bad idea. So you take your compound in here, you heat it up using heating mantle or something, usually not Bunsen burner, water in, water out, and you put the clamps, different clamps. That's a clamp, okay? You can clamp it here, you can clamp it here. I hate when someone clamps up here. It's better to clamp at the bottom, okay? If you clamp it here, you may not need that red, the blue plastic clamp here if you're using one of these metal clamps. So I'll explain what this means. So I wish there was a metal rod here. My son's music stand is here, but he will probably not appreciate if I use it. Imagine this is a molecular model. Imagine this is a monkey bar. It's on your wall. So you can attach by unscrewing it, the clamp, you can attach it. Imagine this is your monkey bar. So you attach the clamp here. I'm trying not to break it. This is secure. Just imagine this is part of your monkey bar, or this is a ring stand. I told you that I hate ring stands because this whole thing can move around. Monkey bar is fixed in space, okay? And then you can attach something here at the other end by turning this knob, okay? This is what the ring stand does. This is what a clamp does, okay? This is fixed. Now this is fixed. The level might be here. You might be just setting up right on top of that lab bench top, but having a clamp will ensure that nothing terrible is going to happen. No one is going to knock it over. When you put your filter flask up here, nothing is going to move. It's secure. So a good chemist doesn't mean that you have to be a PhD guy, a student, or whoever uses. This is part of safety, actually. If you're just going to be setting it up and putting everything on top of it, then you have a hose, vacuum hose, this whole thing might topple. That's unsafe. This is part of safety too. Okay, so this is one kind of clamp. This is a 3-prong clamp. Okay, if you turn it, it moves this way. Turn the screw, you open it up. Again, this screw turns the other end. This is where you attach it to the monkey bar. Okay, imagine this is the monkey bar. You attach it here. I'm not going to break my finger. Okay, and then you can adjust it by turning that little thing. There are all kinds of clamps. There's a funny story about clamps. I'm going to share it with you guys. When I was, before coming to the US, when I was in India, my brother just returned from US. He's a very smart chemist, much smarter than I am. He went to 2 top schools in this country, did his PhD and postdoc, came back as a professor. And I was kind of screwed up at that time. I had really done poorly in my undergraduate because of many reasons, some family problems, death, like multiple deaths, and I was also not as focused as I should have been. Okay, so it was a combination of many effects. So I was with my brother, and there was a guy who was going to that very prestigious institute where I was just auditing. I was hanging out with my brother. He was kind of training me. He was converting a monkey into a human being. You know, I was really in deep trouble at that time. One of the guys who was actually registered in that school he was a very smart guy. He was better with physical chemistry and physics than chemistry. And then he came to the US. I think he came to Princeton to be a graduate student to do his PhD. He wanted to join a research lab in an organic research group. Do you know why he chickened out and he ran away to a physical chemistry lab? He was scared to see something in that lab. These guys. He said, oh my God, there are like 100 types of clamps. I can't deal with them. I can't do this for the rest of my life. So the clamps basically chased him away from an organic career to a physical chemistry career. I don't really know where he is right now. I can Google and try to find out. So clamps can be scary, okay? Maybe there will be a scary movie I'll direct when I make a lot of money and I have nothing better to do. And it'll start with a bunch of clamps. You know, there's a guy who's having a nightmare who wants to be a chemist and make molecules and become rich. And he's scared of the clamps. He said, so many clamps, so many kinds of joints. What does this do? What does this do? What is going on here? Why should I use this? When can I use a 3-prong clamp and when can I use? So he went crazy. Okay. Anyway, so that's that. I don't have a pic. I don't have an example of a. I don't have an example of a test tube, which is kind of a shame. So I will show you. This is something that I definitely do not want to break. A thermometer. Okay. This guy actually has a ground glass joint, but I'm just gonna show it to you like for the sake of argument. Okay. This is not meant to be used because the thermometer itself has a ground glass joint and it's not meant to be attached here. But the whole idea is I'm going to show you, pretend that this is the right thermometer and it's got the right adapter. So the thermometer has to be embedded in here in such a way that the bulb, which should be heated by the gas, should be laying right below this level. It should not be like this because then it doesn't read the temperature properly. It should be down here. Okay, it should be down here, not like this down that it touches the liquid. That's bad. Something like this. The upper end of the bulb should be below this level. Okay, so this pretty much completes the whole distillation setup. As I said, there can be fancy distillation apparatus. You can collect the distillate, what comes out, using a graduated cylinder. This is a graduated cylinder. We joke that it already has an undergraduate degree. I didn't bring the bigger one. Or you can attach A round bottom flask, again, they're not meant to be together. This is 1420 and that's 1922. So they don't fit. It's too small. I don't have another flask. But you get the point. I mean, I could show you, like, you can collect the distillate here, and then you can have a bigger flask there. You can distill whatever you're distilling from there into here. Let's say you have beer and you want to just get the ethanol out. So you put your beer here in a large flask, heat it up. The low boiling liquid will first distill, and then you collect the alcohol here, and it'll pretty much leave the water down here. Okay, that's the whole idea. So that's that. You saw the clamps. Where is the beaker? The simple old-fashioned beaker. There is a beaker. Okay, that's a beaker. That's a 100 ml beaker, just for transferring liquids and stuff like that. If you want to keep some distilled water around, if you want to keep some acetone around or methanol around, because maybe you and 3 other people in that workstation, we have these workstations in our labs, want to use and share, then, or you can, if you want to heat up something in here, you can put it on like a little wire mesh, like a gauze on a stand, and you can have a Bunsen burner or a heating. I didn't bring the stirrer and the heater blocks because they're pretty dirty. They have chemicals. These guys are pretty clean. I didn't want to bring them in my office. My office is supposed to be a clean area. That's a beaker. This is an Erlenmeyer. Erlenmeyers are good for doing crystallizations and stuff like that. They evaporate less. They will, because the mouth, the upper end is kind of tapered. There will be more faster evaporation. If you're just heating something up, or if you're going to be using some water or some solvent, you use beaker and Erlenmeyer, in a judicious way. You have to take the right call. This is a filter flask. This is not an Erlenmeyer flask. This is a filter flask, because you can put a little rubber septum for good sealing, apply the vacuum here. I will regret if I break something today. This is some kind of a tubing. So you attach the tubing here, and we have house vacuum. So the other end, imagine this is not there. Other end goes into your house vacuum line. Once you turn on that stopcock, then you're applying vacuum here. Then you can do a vacuum filtration using a funnel, and this funnel is a vacuum funnel. It's called a Buchner funnel. You can see the holes in there, and you use a filter paper that just sits right inside that surface, just covering all the holes. It should not be folded on the sides. We will talk about these techniques later on. Okay, this is a vacuum filtration. You do vacuum filtration when you need the solid and not the liquid, not the filtrate. Let's say you recrystallize something you recrystallize sugar from water, from your last night's lemonade party, okay? And you recrystallize that when you have to be really a penny pincher to recrystallize your sugar from the leftover lemonade, but this is just for the sake of argument. And you're collecting the sugar that crashed out from water after you did the recrystallization, and you're collecting it here. So use a setup like this, maybe a larger Buchner funnel. This is not the only size. You can get tiny ones, you can get a huge one, and you have to use the right size filter paper just to sit flatly on top of it, covering the holes, not folded on the side. That's bad technique. We'll talk about it later on. Then you put it down here. This is for creating a good seal. If you just stick it, I hope I don't do anything bad today. If you just stick it here, it's not going to create a good vacuum. The whole idea is to create a good vacuum, and this is some kind of a vacuum adapter. And then you're applying, this is connected to a vacuum line. So this is applying vacuum. It's going to suck the water or whatever liquid you have through this place into the filter flask, keeping your solid dry on top of the filter paper. And you can keep it on for some time, and then you can dry it more in air, so on and so forth. So that's a Buchner funnel. That's a Buchner funnel. This is called a Hirsch funnel, H-I-R-S-C-H. I think they're all names of different chemists. HIRSH, and this is Buchner, BUCHNER. There might be an umlaut, probably a German guy. This is for larger scale, 1 gram, half a gram, 200 milligram. If you're dealing with like tiny little amount of material, use the harsh funnel. Use a tiny little filter paper. You don't use a huge filter paper and fold it up. That's terrible technique because it's not going to create good vacuum. You just use a tiny little filter paper, stick it there, wet it with little solvent, whatever solvent you're dealing with, press it down, turn on the vacuum, and it's going to sit tightly in there. Okay? Harsh on your left, Buchner on your right. Okay? And they can both use the same adapter. This should work here too. Okay? So those vacuum filtration devices are for the situation when you need the solid and don't care about the liquid, the supernatant liquid, the filtrate. When you need the liquid and don't care about the solid, then you use a regular filter funnel. Okay, this is a regular filter funnel. Some filter funnels do not have the stem. It's cut from here. It's just this much. Okay, there is a reason for that. You can think about it. That could be a bonus question. My quizzes usually have some bonus questions, but the bonus questions will always require you to know a little bit more, think a little bit more beyond the level that we are all dealing with. Okay, that's that. What else? I wanted to show you, where is my pipette? I had a pipette. Oh, there you go. There you go. This is something that you're going to be using every day in a real lab. This is a short pipette. I didn't bring the long pipette. They're disposable. Once you use it, you throw it away. This is kind of like a medicine dropper. You have seen it in the past. This is a pipette bulb. Okay, we don't get the medicine dropper kind of a setup, but we kind of make it ourselves. So you kind of attach it here. I'm just sensing that something is going to go wrong today. Maybe I'm paranoid. Okay, now this is your medicine dropper. So by squeezing it and inserting it in some liquid, you can suck it up, and then you can add it. This is just for transferring liquid from one place to another. Smaller amounts. When it gets too much, then you pour it or use a graduated cylinder or something like that. So, okay. Once you're done with it, you throw it away in the broken glass waste container. Okay. That's that. What else? These guys are sometimes used as a little rubber septum for covering it. You can, if you're running a reaction, and if you wanna, I have it here somewhere. Where is it? Oh, there you go. This is a syringe. If you want to add a precise amount of reagent, sometimes you may have to do that. I don't think you can read it here. It's a 1 ml syringe. I don't know if you can read it. It says whatever 0.1, 0.2, 0.3, 0.4, 1 ml. So this is 1 ml. Somewhere here, it'll be 0.5 ml. This is just like a syringe, and that's a needle that goes on the top. And if you're adding 0.5 milliliter of something into a running reaction, you can have a setup like this, and you can insert the needle through this rubber septum, okay? And then you can add it, something like this. Then you pull it out without disturbing the whole scenario. Something cool you must know, that we have to sometimes use a little device. Where is that? Where is my there you go. Where is my star bar? I cannot pronounce star bar. I've been mocked before. I wish there were some bonus points for this. Why do you think we will do something like that? And what is it? This is pretty cool. What is this guy? Anybody has any idea why would you dump it in this round bottom flask when you are running a reaction, and what would it be doing? This is like a
So
little.
it can
Say that
mix.
again, Sandra.
So it can mix.
Say that again.
So it can mix.
Mix. It can mix. It's incomplete answer. I do not know what you're talking about. What can mix? The stir bar can mix.
The if there's any liquids or
If there is liquid, I wish there was a metal something here. Let's see if I can work. No, it's not there.
oh, it's magnetic.
It is magnetic. I'm looking for a piece of metal. No, it's stainless steel. Darn it. Do I not have any metal key in here? No. No. That's frustrating. I have a wheel lug board. That's not it. That's pretty pathetic that I don't have any metal object in my office. Okay, sorry. No, I guess the answer is no. So that's magnetic, and you place it on top of a little box that can usually do two things. It says that there are two knobs. One says stir, and one says heat. So that when you turn on the heat, it's connected to the AC outline, alternating current, 110 volt power outlet. Once you plug it in, and you attach it on top of that thing, that little square box, it can either heat up the top surface, or when you stir it, there is a magnetic disc underneath that you cannot see that starts to turn. As it starts to turn by magnetic induction, it also starts to turn this guy. It starts to spin. I promise next time I'll make a demo of it by showing you something. I can't think about anything that's metallic. Yeah, it's unfortunate. It's a shame that I cannot find anything metallic. So as it starts turning, it churns whatever is inside. Okay. Otherwise, the other option will be for 4 hours, some guy is going to be doing this. Okay, that's ridiculous, right? We are all efficient, not lazy. So as it turns, it mixes things. So aren't you worried that the material can actually react with your chemicals? What do you think is this white coating made from? It's very slippery. You have seen it in your kitchen, in your bowls, excuse me, when you're cooking and it's supposed to be slippery. It's a T word. You don't know? Really? It starts with T and ends with N, N as in Nancy. Some of the bowls are coated with that inside so that your food and materials don't stick to the metal part. What is it? It's a T word. Come on, somebody, say it. Jillian, do you know what I'm talking about? What is this coating made out of? It's a synthetic material. It's a polymer. Sometimes in the past, it used to contain a halogen, which is what makes it kind of dangerous. Teflon. It's made out of Teflon. It's inert. So it prevents any chemical to touch the metal surface and mess things up. If you just put like a metallic, like iron bar, iron will react with many things in the real life, and it's going to completely ruin your system. The stir bars come in different shapes and forms, like the tiny ones, like really tiny, like maybe a few millimeter long and a very, very tiny. This is a 1-inch stir bar. You can get a 1/2-inch stir bar. They can get different shapes and forms. What else? I have shown you the syringe. I've shown you that. This is called, you have seen it in the kitchen, this is called a mortar and pestle. What's the purpose of using this? Mortar and pestle. Why do you use it?
Question.
Just it seems like just one person is answering all the questions. I appreciate that. Can somebody else also like pitch in? Are you guys too tired or too uninterested, disinterested to participate? Or?
To grind things like a fine powder.
Thank you. Separatory funnel. That's a stopper on top of it to close it. Sometimes when you are mixing something, let's say you have made tea. You have boiled tea in water, filtered it. Now you want to extract the caffeine from that water using an organic solvent, okay? So you put the tea water down here, you add some acetone that's going to be floating on top of it, and then you close this, make sure this stopcock is closed, otherwise it's going to be a disaster, okay? Then you kind of shake it by venting it every now and then. Shake it so that all the caffeine from water gets into the acetone layer. Acetone is not going to work. Methylene chloride. There's a reason why they will not work, okay? The two liquids must be immiscible so that they make layers. Then you clamp it, then you undo the top, then this is probably too small, but you get the idea. You use a ring clamp, okay? It's too small. You use a bigger one to kind of hold it, and then let the layer separate. Then by slowly opening the stopcock, you lower the bottom layer. Whatever the bottom layer is, whatever the top layer is, you can separate the layers. Then you can get your methylene chloride layer, organic layer, with the caffeine, get rid of the solvent, and then you have your caffeine. So this is how you can extract caffeine from water. That's one of the techniques. Okay, that's a separatory funnel. What else do I have here? I think that's pretty much it. These guys are called spatulas. What do we use spatula for? Let's say you have extracted 100 milligrams of caffeine from water. Now you're going to be taking a weight and you're going to be submitting it to your instructor for final analysis. And this is where you're going to be submitting it. And your caffeine is sitting on a piece of paper and you're going to be transferring it using the spatula, okay? Like this, or a bigger spatula. This is just bigger, different sizes. So these are different things, okay? I don't have an example of a test tube, but test tubes usually don't look so fancy. They don't have the gradations, like the graduated lines. It's not tapering down. It doesn't have a ground glass joint. It's just an old-fashioned, simple, really boring looking tube. They're pretty cheap too. Do you know what this is? Anybody has worked in a research in an analytical lab? Anybody has any idea? And you always need two of them together to do something special. No? You use it in a centrifuge. We'll discuss it later on. These are called centrifuge tubes. When you have some solid mixed in a liquid and you can't separate them, you cannot filter them because it looks like a slurry mixture. You can't really filter. It's going to make a mess. It's too little quantity. So then you have one of those mixtures here. Then you put water or something in the other one to make sure they're balanced. You put it in a centrifuge tube where there's a round disc and there are holes to hold these centrifuge tubes. You put them in there and you spin it. As it spins, the centrifugal force pushes the solid down here because they're slanted, kind of like this. As they're spinning, the centrifugal force pushes the solid down and they get stuck at the bottom like a little cake, and the liquid becomes like a clear liquid on top of it. And once your centrifuging is done, you pour out the liquid and you have the clean solid at the bottom. So this is what centrifuge tube looks like. I think I don't have anything else to demonstrate. There are some fancy things here to demo. I don't think I want to do that. This is called a melting point capillary. when you have, let's say you have collected the caffeine and it's all dry and good. So you need to do a melting point. So you need to melt it while you're watching the temperature of that melting device going up with as you're heating it up, and you're measuring the temperature using a thermometer. This is called a melting point capillary tube. One side is open, one side is closed. You just somehow manage to put, you can kind of tap it on the caffeine or whatever solid you have, acetaminophen or whatever solid you have. You're trying to check the melting point. You kind of tap it there. You get a little bit of that solid in there. Then you have to tap it on a hard surface. Sometimes you can run it through a little straw. So sometimes I bring straws from McDonald's or Starbucks for my students. And if you throw it on the upper end of the straw like this, imagine this is an empty straw and there's a hard surface at the bottom. If you just drop it from the top and it just goes and hits the ground really hard, what that does is that brute force just pushes the compound from the top into the bottom. So your compound must be at the closed end. Then you stick it inside your melting point apparatus, turn it on, slowly start heating it up. You can, through a little magnifying lens, you can see this is expanded, like enlarged. You can see the solid really clearly. And you can also read the temperature using the thermometer. And once it starts to melt, the melting point starts there, like 120 degrees. And then when everything is melted, then let's say it's 123 degrees, then you have measured the melting point of this particular solid from 120 to 123 degrees. It's always reported as a range. That's that. I think that's pretty much it. I wanted to do this demo. This is not perfect. I know it's far from perfect. And I wanted to do this in the real lab. But right now, I think go through the modules, answer the questions. It's pretty straightforward. And I will be asking questions from list of glasswares, whether you like it or not, in the first quiz, whenever the quiz is scheduled. Okay, so that pretty much ends this week's lab. I'm crying, imagine, bad mood. You can always ask me to set up a Zoom meeting with you if you have any questions. It's just very awkward for me to turn on the Zoom, the office hours, and nobody shows up. So please, I'm urging you, begging you to write me an email. Don't feel uncomfortable or inhibited. Just say that, Dr. Maitra, I have a few questions. I don't understand certain things. Can we meet? I can call you. I think Zoom is probably better. So let's do Zoom. We can record it if you want. I can share it with you, whatever. So I can set up the Zoom office hours anytime you want, according to our mutual convenience, and we can go over stuff. And before the quiz, usually in the past, I've always thrown like a review session, going over all the materials, probably usually from like approximately 2 hours. So if everything is going well, and if I'm sick, not sick, I'm well, and everything is good, the Central Valley is still there in Central Valley, then he will be hearing from me before the quiz. We'll have like a little review if you want to join. If you don't want to join the review, that's totally fine. So we'll have a review. I'm going to add a link for the ChemDraw, where you can go and download the ChemDraw app from the store using the Fresno State ID. I have it somewhere. I'll have to find it, and I'm going to post the link in an announcement, and we'll go from there. Try to finish Module 1. I'm going to set up a deadline for you guys to do this probably by Friday midnight. Is that good enough? Because there is not much you can do. I don't want to rush you guys. You're probably taking other classes. So we can set up something like that. And I want you to spend the weekend, or Monday is a holiday, right? Can you guys give me a thumbs up if that's true? Is Monday a holiday? Is it Labor Day?
Labor Day's on September 7th.
Okay, September 7th. Okay, so we have class on Monday. Oh, Monday is 31st. Okay. Yeah. So yeah, I would download ChemDraw by the weekend if I were you, not wait until the last moment. And Monday, I would like you guys. I mean, I'm going to go through the ChemDraw and play with it a little bit. I want to show you a few tricks. We'll have some homeworks to do from there. So I would say that wrap this thing up as soon as you can, finish it off, and then start getting ready. So I'll try to add the link for the ChemDraw as soon as I can. I'm going to just search ChemDraw in my email, find that link, and I'm going to post it on an announcement in Canvas. If you want to talk to me, just let me know. Okay. Any other questions right now? I'm going to switch to the front camera and maybe I'll wait for like 5 minutes or so in case somebody has any burning question.
I have a question.
Sure.
Is there supposed to be an assignment for like the glassware and stuff we just learned? Because when I click on the, like, you have like an assignment, it says no content on it.
There are questions right at the end of the module, right? Don't you?
So I clicked that and then it says no content on it. Like there's nothing like there.
Okay, I need to investigate because I need to check with Dr. Mohalski.
Yeah, the questions. Oh, sorry, I have a question too, but go ahead. Yes.
No, you go ahead because I need to figure it out. I thought that there are some questions. Yeah, go ahead, Esteban.
So like when you said the questions on the bottom of the like each different like for the module, they're just like different articles. They're not actually questions. Like so, like one will be the clamping and the other one will be the
Okay.
drying.
I would have. Okay.
I don't know if that's just on my end.
No, that's totally fine. I do not want to, because it's, I think, how many labs are going on here? I don't know how many labs, but a bunch of us are teaching this course. Dr. Mohalski, me, Dr. Kalyan Munshi, Sammy Tamras, and somebody else, whoever that person is, maybe 4 or 5 of us. So I don't want to do anything differently for this course if there is no quiz. For some reason, I thought there were some questions about glasswares, just to keep you guys on your toes. Okay, here is what I'm going to say. That means there is no questionnaire for the glasswares, but please do not take it lightly, because in the quiz number 1, which is going to be written by me, I will be asking you not like tricky questions. I just want you to know the basic glassware setup, how you set things up. Just read the modules. My questions are going to be pretty much from the modules or whatever we discussed today. Okay, some simple common sense based questions. So make sure. I'm sorry, my bad that I missed that link or that information that there are no questions or quiz at the end of this module. That's fine. I'm not going to change it. I'm not going to dump any additional homework on your shoulder. That's totally fine. But please spend the next few days this week learning the glasswares. Make sure that you understand which is which really well, because you don't want to study the glasswares at the last moment, the night before the quiz, because I think other classes are going to probably start, putting some pressure on you too. Okay, so yeah, thanks for asking. I really appreciate it. And whenever you see something that's a little off, or I might have misspoken, or I might have misguided you or said something wrong completely, correct me, okay? Because I do, sometimes I'm just trying to do too many things at a time. I'm also trying to file a patent and write a paper and working with a patent lawyer and some other problems in life. So I can be distracted, and as you know that this is the first time I'm teaching an organic virtual lab, so I might make mistakes, so correct me. Please correct me, and it's not going to hurt your performance. Okay? Otherwise, wait for the ChemDraw link, and then we will meet on Monday. Sounds good? Take care and have a good day. I'm going to hang up. Okay. And I will eventually post the video.